I'm sure you've heard it before that huge Hulk-like bodybuilders don't have functional muscle, or you may have seen the videos of smaller guys lifting huge amounts of weight. But what if I told you that these differences can be explained by how the muscles adapt to training on a cellular level? We know that hypertrophy is a process by which muscles grow in the body, but hypertrophy has two different parts: myofibrillar hypertrophy and sarcoplasmic hypertrophy. To understand these two processes, you need to know that your muscles are made up of muscle fibers or cells, which in turn contain the myofibrils and sarcoplasm. The most important thing to remember about the myofibrils is that they are the functional unit of muscle fibers. That means they facilitate muscle contraction, muscle lengthening, and production of power. The sarcoplasm is a fluid-filled region around the myofibrils. It contains various nutrients like water, glycogen, and ATP, as well as the mitochondria, and helps to sustain the myofibrils. With this in mind, it makes sense that myofibrillar hypertrophy leads to an increase in the diameter, length, or even amount of myofibrils in muscle cells, and therefore an increase in strength, whereas sarcoplasmic hypertrophy leads to an increase in the size of the sarcoplasm, but by itself not an increase in strength. It is important to note that myofibrillar and sarcoplasmic hypertrophy occur simultaneously after a training stimulus. This means you can't isolate myofibrillar or sarcoplasmic hypertrophy on their own. However, the two processes will occur in different proportions depending on the type of training. For example, higher rep ranges and lower weight will disproportionately increase sarcoplasmic hypertrophy over myofibrillar hypertrophy, but lower rep ranges and higher weight will disproportionately increase myofibrillar hypertrophy over sarcoplasmic hypertrophy. So, does bigger muscle mean more strength? Because both types of hypertrophy occur regardless of the type of lifting stimulus, an increase in muscle size also leads to an increase in strength. That's why it's not entirely accurate to say bodybuilders don't have functional muscle. They likely have more myofibrils than most people, but their muscles are also likely composed of more sarcoplasm than most people as well. Powerlifters, on the other hand, will typically adapt much more towards maximal force production, potentially by having more myofibrils or functional units that they can utilize during a lift, which is why they can be smaller but also stronger. Of course, the caveat to this is that neural recruitment plays a significant role in strength as well, but we will cover that in a later video. Both bodybuilders and powerlifters achieve vastly different physiques and ability levels depending on their training and the muscular adaptations it emphasizes. The practical takeaway is that your training should reflect your actual goals as an athlete. That way you are benefiting from resistance training and not being held back by it.